Let's go.
Do we have work time?
It depends on how long it takes us to get through this stuff. So, first full week, second semester. Yeah. Kind of weird to say that, being that it's middle of March, but it happens. So, yesterday we took a quiz, and then today we'll start with section 2.3, and then that will take us, we'll do section 2.3 today. We'll talk about sequences today. On Monday we'll talk about series. Tuesday we'll have a formative. Wednesday we'll do application problems. Thursday we'll take a quiz. And then next week, Friday, we'll start with infinite geometric sequences and series. We'll do that Monday and Tuesday, Friday and Monday. And then, I'll add Friday, Monday, and Wednesday. And a formative, and then the test in there too. Okay. Good time. Okay, and then it's spring break. Okay, pushing through to spring break. All right, so for the last week, we've been talking about arithmetic sequences and series. And arithmetic, we do what to find the next term? Add. A, arithmetic, A, add. Okay? So we're adding. Geometric is a little different. Okay? Because we're not adding anymore. It's a sequence that has a constant ratio between consecutive terms. Okay? Now, that's kind of a hoity-toity definition of a geometric sequence. If we're not adding, because when we're adding that's arithmetic, what operation do you think we're going to do to get the next term in a geometric? We're going to multiply. Yep. Okay. So a geometric sequence, we multiply to get the next term. Now, that ratio thing that it's talking about up here, that common ratio, or constant ratio, common ratio, constant ratio, ratio, all mean the same thing. Okay? We're going to call that R in geometric. Okay? In arithmetic, we call that difference D. Okay? Now it's a ratio. And so the reason it's called a common ratio is because we can take any term and we can divide it by the previous term. No matter where we are in our sequence, if I take a term and I divide it by the term right before it, I get the same number. Okay? And that's how we figure out R. If we can see it, I'm multiplying by 4. Okay? Great. If you don't see it, you can take any term and divide it by the term right before it, anywhere in the sequence. Okay? And that will get you R, the ratio. Okay? So, here's some examples of sequences. Now, later on in this chapter, I'm going to just give you a sequence, and I'm going to say, find me the rule, find me the term, this specific term. Okay? So the first check you should always make is, can I add something? Well, I'm adding 2 there, but I'm adding 4 there. So that tells me it's not arithmetic, because that difference is not the same. Okay? So not arithmetic. But I can multiply by 2 and multiply by 2 and multiply by 2 and multiply by 2. Okay? So that tells me that it is geometric. With an R value of 2. Is it arithmetic? Yay or nay? Why not, Luke? So the first one would be minus 100, right? And so then the third term should be 0 if we keep through it. It's not. Okay, so it's not arithmetic. Is it geometric? What's the ratio then? Half? Okay. Because if you don't see that the ratio is 1/2, okay, we can take any term, 100 divided by 200. Simplifies to 1/2. 50 divided by 100. Simplifies to 1/2. 25 divided by 50 simplifies to 1/2, and so on and so forth. Okay? So our R values can be whole numbers. Our R values can be fractions. What about in this one? Right away, it's not arithmetic. And I know that because it switches positivity between terms. So I know that that's not arithmetic. Is it geometric? What do you got, Logie? Multiply by -2 each time? Yep. And so we're always multiplying by -2 to get the next term. Now, so we can have positive R values, we can have fractional R values, we can have negative R values. Okay? All good. One thing that will make this section easier for you is if you embrace your love of fractions. Okay? Okay? It's going to make it so much easier for you to keep everything in fractional form. Okay? So instead of 12.5 here, it would be easier for us if this was 25/2. Trust me, fractions are your friends. Okay? Okay? So, determine if the sequence is geometric. If so, find me the common ratio. First one, geometric, not geometric. Not geometric. What is it, though? And what's our common difference? Yep. Second one, geometric, not geometric. Geometric, common ratio? 4. Third one. Geometric, not geometric. Geometric, common ratio. What? Negative 1/3, yep. Fourth one, geometric, not geometric. Not? Is it arithmetic? What's our difference then?
You're adding by 2.
Yep. Okay. So just like with arithmetic sequences and series, we need to have a rule that we can find so that we can find some term later on in the sequence. Okay? And here is that rule. Any term in the sequence is equal to the first term of the sequence times the common ratio raised to the n-1 power, where n is the term number or the number of terms. So in order to find the rule for a geometric sequence, we need to know what the first term of the sequence is, and we need to know what the common ratio is. If we don't have those two, we need to find them. So just like we had last week, Friday, when we were doing arithmetics, there's different styles of problems that we can have. The first style of problem is, here is a list of the sequence. List of numbers. Okay? So the very first thing you need is you need the first term. So G sub 1 here is 4. The next thing you need is you need the common ratio. If you didn't see that it was 2, you could take any term and divide it by the term right before it. And you would get 2. Once you have that, now we can, or once you have those two, we can go right to the rule. And the rule in this particular sequence would be G sub n, any term, is equal to 4 times 2 raised to the n-1 power. Probably going to be beneficial for you to always put your r in a set of parentheses. So that's our rule. Then it went on to say, now that we have our rule, let's find the 7th term. So we need to find G sub 7. So I'm going to plug 7 into my rule in place of n. 7 minus 1 is 6. 2 to the 6th power is 64. 64 times 4 tells me that my 7th term is 256. What I'd like you to do now is I'd like you to find me the rule and the 7th term based on sequence B. So my first term is 2/3. Agree? Okay. Common ratio. Any term divided by the term right before it. Thinking back on fractional math, how do I divide fractions? What you got? Which one? The second one or the bottom one? Okay. So I got to reciprocate it, and when I reciprocate it, that means I do what with it? But then what do I do? Multiply. Yep. Okay. So I flip and multiply. So that's going to give me an R value of 3/4. If I have an R value of 3/4 with a first term of 2/3, that would give me a rule of 2/3 times 3/4 to the n minus 1 power. Okay. Then to find the 7th term in that, seven minus 1 is 6. Three-fourths to the 6th power is 729 over 4,096. And then the nice thing is that 729 can be divided by 3, and I get 243. 2 goes into 4,096 2,048 times. So in the end, my 7th term is 243 over 2,048, which frankly is much easier to write than the decimal equivalent of it. I don't even know what the decimal equivalent of it is. It's what? A lot of ones. Okay. Okay. So that's the first style of problem. Next style of problem gives you any term or some term in the sequence and the common ratio. If that's the case, then negative 16 is going to equal my first term times my common ratio raised to the, since negative 16 was the 6th term, 6 minus 1 power. So that's 2 to the 5th. 2 to the 5th is 32. Actually, let's rewrite this as I like that better. Divide both sides by 32. But do I like negative 16 over 32? What do I like instead? Negative 1/2. Yep. So now I can write my rule. G sub n is equal to negative 1/2 times 2 to the n minus 1 power. You find me the rule if the fourth term is 12 and r is negative 3. 12 is equal to my first term times negative 3 to the 4 minus 1 power. 12 g sub 1 negative 3 cubed. 12 is going to equal negative 27 times my first term. Both of those can be divided by 3. I like negative 4/9 as my first term. So my rule then would be negative 4/9 times negative 3 to the n minus 1 power. Yes'm? Okay. Next style of problem, you given 2 terms. Okay. Just like in arithmetic, when we were given 2 terms, you use the rule on one term, and then you use the rule again on the other term. So this is going to tell me that 48 is equal to, oops, that should be a G, my first term, times r raised to the 4 minus 1 power, or simply put, that 48 is equal to g sub 1 times r cubed. (1,536) is going to equal my first term times r to the 9 minus 1 power, or simply put, 1,536 is going to equal g sub 1 times r to the 8th power. Now last week we said, okay, now we set up a system of equations and we substitute or eliminate or graph it, and we get what it is. Okay? This one, we can't. Because the g sub 1, the first term, and r are together in a term. Okay? So I can't do a system of equations. So what I need to do then instead is I'm going to take one of them, and it doesn't matter which one, but I'm going to take one of them and I am going to solve for G sub 1. Which means I'm basically going to divide both sides by r cubed. Follow me? Now, what I'm going to do is I'm going to take that and I'm going to substitute it into the other equation for G sub 1. What does my right side become? The reason way back in we were doing exponent rules way back. What does my right side become? What? Just r to the fifth? 48 r to the fifth. Yep. I want to solve for r. We saw it. Well, what will we do next? Not subtract 48. Divide by 48, because we're multiplying by 48, so divide by 48. Okay. 1,536 divided by 48 is 32. Now what? What thing? Which root am I going to take? The fifth root. I'm going to take the fifth root on both sides. And what is the fifth root of 32? 2. So my common ratio is 2. Did you just have an aha moment? Because 2 times 2 times 2, let me start over again. 2 times 2 times 2 times 2 times 2 is 32. By now you should know that 32 is 2 to the fifth, but there is a way to do it in your calculator, yes. 5, 5, second, caret, your exponent thing, 32 equals. Yep. So I've got r, I still need G sub 1. So now what can I do? What? Plug 2 back into this one, right? Okay. So now I'm going to plug 2 back in there. So that's going to give me G sub 1 is equal to 48 divided by 2 cubed. What's 2 cubed? 2 cubed? 8. 48 divided by 8? 6. So my first term is 6. Which makes my rule be 6 times 2 to the n minus 1 power. Okay? What I'd like you to do now, find me the rule for f. I get g sub n is equal to 1 times negative 3 to the n minus 1 power. Or, because it's 1 times, we wouldn't have to write it. But it's not wrong if you do write it. Questions on that one? Let's try one more with that one. Walk me through it. What's my first equation? Because it's 4 minus 1. Love it. Second equation is what?
3072 equals G1.
G sub
Or
1.
G sub 1 times R to the 10 minus 1.
So that's 9. Which one do you want to solve for G sub 1? Blue? Agree? Plug in. Oops. Got ahead of myself there. So 3072 equals 48r to the 6th. Divide by 48. What do we get? 64. Then what? 6 the root both sides. What do we get? No. Why?
Because if you, I don't know, just remember.
Say it louder so everybody else can hear.
Plus minus 2.
Why? But why?
Because it lands on the E.
What was that?
It lands on a positive 64 if it's negative. Like, you know, if you keep doing it, it's a positive no matter what.
So anytime we are taking an even root, we have to add the plus or minus. Which in this case, we were taking an even root. We're the 6th root. In the last 2 cases, we took odd roots. We did 5th root first, we did 3rd root second. Okay? But in this case, we're taking an even root. Oops, I'm missing. There you go. Okay? So that means now when I go back to find my G sub 1, I have to do 2 different ones. When R is positive 2, then G sub 1 would be 48 divided by positive 2 cubed, which would be 48 over 8, which is 6. When R is negative 2, then it's 48 over negative 8, which is negative 6. So I get 2 different rules here. One rule would be G sub n equals 6 times positive 2 to the n minus 1, or G sub n equals negative 6 to the negative 2 to the n minus 1 power. Now, it just so happened to work out that the positive R value gave me the positive G sub 1 in this case. That is not always the case. Just because it's positive R doesn't mean it's going to be a positive first term. Negative R, negative first term. That's not the case. Okay? That is totally different from, or that's just happened to be a coincidence. Okay? Here is your homework. It will be due on Monday. Again, just find me rules. No need to graph these out. Next Tuesday, you'll have a formative. Next Thursday, you'll have a test.